In this chapter, I will start working on the constraint for the simulations. Okay, so we have all the proxy here ready, and we have a clean and organized scene. I will start with the band proxy. So I will select the top parts of the band and the bottom parts for pinning this area to anim. By selecting this geometry, we have 2 or 3 different ways. You have a lot of ways, but like the common one is group, and we can name the group. Let's, for example, here the name, we'll call it $OS. This will take the name of the node itself. So if we select here, we have a group 1. If we rename it to band underscore bin, it will pick this name. So this is easier for cleaning up the scene and also having the right group name looking good. Okay, so the first way is selecting geometry by hand, like this, for example. And the issue with this way, if you have updated geometry and you update the proxy, for example, let's go 51, and all the selection will be gone. So this is non-procedural way to select geometry. But in some cases, you have to do it, but try always as much as possible to do it procedurally. So if we go like with a bounding box, for example, this area, we convert this to a sphere and select this bottom part. If we like to switch to points, it will also work because it's based on the bounding. But if you are selecting like this and you are converting, it will be an issue. So try avoiding selecting with the point or primitive. Okay, this way, and you can add another node, and you have to name it exactly the same, like this. This. Okay, so now it's the same name, and if you are selecting different area and you union with existing, you have multiple nodes selecting the same group. But also this way, you have to add multiple nodes, and you break the. As you can see here, we have OS, but here we have to go back and put the right name because this name is overriding the other name. So this way is good in some cases, but also there's another way, which is group and group by lasso. This way also we rename it, and we don't need this, like this, and in this way its group type is point, and this is what we need, points. And if you press enter in the viewport and select, start drawing a curve, this curve will do like a projection and select the area. And if we go back and change the point count, it will stay selecting the same thing because this is based on a projection and the area is selected. Okay. What I like about this selection is you have the freedom to select like multiple curves at the same time without adding multiple nodes like a group, and you have a bounding box and the sphere only. But this way you have like a drawing curve as you like. So this way you can select more freely and have multiple curves at the same time. So this, with one node you can select multiple areas and you have easier way to select. So it depends on which one you like. And also this is a select visible only. We can untick this, and if you select, it will be select both sided. So I like this one. You can pick whatever you like, but in this case I will start selecting all these geometry one by one. I will select the area will be pinned to anim, and I will start after that working on the constraint. Okay. Yeah, I'm selecting one by one really quickly here. Copy and paste, clear the selection and reselect from scratch. The group by lasso is a good node to use if you have updating geometry. And this one I'm trying to select it based on the point count. I like selecting because with the group by lasso it will not be easy. So sometimes you have to go with the selecting primitive or points, but try to avoid as much as possible. Okay, now we selected everything and rename it. So now I'll start working on the constraint itself. Okay, I'll add a balloon. Very close. Okay, this one. I add the first the cloth constraint. So the important thing we are looking at first is the thickness of the geometry. I think this is good. We are also will work on the layer because we have multiple layers of cloth. We is good to have this piece. It's good to have this layer attribute. It's a default. It's defined piece from connectivity, but now we are like having multiple branches, and this way it will tell the solver easier these are different layers, and it will try to avoid each other, not going inside each other. So I'll start with the 100. This is the layer number, and I will work on the bend stiffness and stretch stiffness here. Okay, so I will try to leave it at the default first, and when we are start working on the solver, and we do like a first simulation and we see how it goes. After that we are start tweaking based on that, but in some cases we do add like this Venom solver. This is what I was doing sometime, like doing a Venom solver, and this bin. This is just for test. I add the bin point to the bin to animation, and I did like a quick test and see how it behave. based on that, I started tweaking the bend stiffness. Okay, I think let's leave it at the default for now, and we'll start working on the changing these attribute later on. But mostly I try to disable compression stiffness and have like a damping ratio 0.1 in the bend, so we have a smoother bend behavior, and we can decrease the bend stiffness, but for now let's keep it here, and let's do all the constraint for everything and go back. Okay, I will add a venom back here, so this we will back everything together, and after that we merge it. After that we do unback for everything, and we pipe it onto the solver. So in this way, this is the main thing why I'm using this horizontal method, not vertical, like everyone on top of each other and selecting the group for each one. But in this way I'm going with a horizontal. So let's, for example, take these two. Okay, this is the first one and this is the second one, and we merge it like this. After that we unback it, unback venom. Okay, after that we are pipe this directly to the solver. Make sure we are updating the pinpoint, and when we are like solving this, it will be working together, both geometry working together at the same time. And if we have like an issue with one of the geometry, we are piping this directly to the issued geometry, and we do the solver simulation and we see where is the issue, and after that we connect it back to the original merge. So this way it's easier to debug which one causing the problem or causing the issue. And this one also will calculate one by one, but when you have like these like on top of each other like this, it will be, if you have to update this one, it will calculate everything at this. It calculate everything. If you update this one, it will be updating all this, and sometimes in SOPs it's causing some issue where it's not updating, like it's, if you update this one at the end, it's not updating the setting, and the solver will behave the same thing without updating. But this way it will be horizontally, and it will be always updating in the right way. So this way is much better in most cases. Also, I want to mention, sometimes you have two different pieces, and for example you are looking to glue these two pieces together, so you can add a venom constraint here, and like add, for example, glue, and you can do this from this geometry to this geometry, and you can have like a secondary venom constraint node here after the MBake. So this way you have like organized system. These like the glues or the stitch or anything you like to add here, and this only for each one, like bento, animation, or glue or strass. So always you have easier way to go back and fix or debug the geometry one by one and quickly, because you can see all of them. Okay, let's continue. Now, as you can see, I'm working on one by one, updating the constraint really quickly. I'm copying from each other, from node to node, and updating based on what needed to change. Like sometimes add a stress volume constraint, and sometimes glue, sometimes we have a shape match. It depends on the geometry. Doing some tests during like building the constraint is always good, so you can see the behavior before you do the simulation on the whole character and the whole animation. Shape match is always a bit heavier to calculate because I have a lot of constraint in between the pieces on the point, but it gives you like a solid geometry. So I try to avoid shape match if there's no need for it, but when you have like a metal, you can use a shape match. This way you will have a solid geometry. I'm doing some test here to see how it looks, because this is very fast to calculate. If you do it uh, with the whole character, it will be so slow. I'm renaming, organizing my scene, and cool. Now I have everything set up, and now I will go for most of the complicated one, and I will explain what I did. So, for example, this one, I did a similar thing. I don't tweak too much in the bend stiffness and the stretch stiffness. This will go like after I will do like a first simulation. After that, based on the simulation, I will take each one and start working on it. But for this one, I was talking about this having multiple primitive, and I did a constraint glue in between the pieces. So I have a 10 constraint per point for these. So this node will connect the pieces with each other and stay together in the simulation. And for example, this one, this is similar thing. We connected all the pieces together, so we maintain the whole shape. And let's go to this one, the back, for example. This is a bit complicated. Complicated compared to pants, for example, because we have a cloth, strass, and glue. So this is a cloth. We don't change anything. We make the bend 0.1 because it's not bending too much, and we have a struts with a constraint bare bones like 10. So this will, if we go back to 1, this will be less, maintaining the shape of the bag. If we go like, for example, 100, it will try to add more constraint, and this more constraint will try to maintain the shape even more. And what you can do also is adding another stress constraint, and you can keep one like this and do another one with a long constraint, and this constraint will be in between the body. So this two stress constraint will maintain the shape even more, and you can like play with the ray offset, and you can have like a long constraint. This from this area to this area will try to keep the distance and maintain the shape, but this you can use for object you like to maintain the shape even more. But in this case we are good with just one, and after that we glue all the pieces together. And the bin, we know the bin, and this something similar. This is something similar. It's a soft body, so it's gonna be bending a bit. But let's go to Under Metal. This one I use a shape match, so I'm trying to maintain the shape, the whole shape. It's like a metal, so we don't need it to feel like a cloth. So with a shape match, we are trying to match the shape. But when you are using a shape match will be a bit slower to calculate, and if you increase the sub steps, will have a better result. But it depends on your simulation, how much intense are like the colliding or the stress on this object. So for example, this one, in the animation, it's bending too much. We like to keep the original shape with a little bit of bending in between the pieces. With that, we have a glue. We can decrease the stress stiffness in this, for example, and this will have like a little bit less, or we can increase the damping ratio. So with this way, we have like a little bit of freedom between the pieces, so we can feel like it's bending, but this will keep it for later. And the same thing for knee. So I will show you what I mean with this one. If we go to the animation, let's go to stream frame. Okay, so this is bending too much based on the rig, and this is not good. This should be straight always, because this is a metal. So with the shape match, we'll have it maintaining the original shape always. So if we go back, so this way we are constrained bend to anim in this area only, and when it's this, we try to keep the shape always. So this is one of the reason why we use shape match here. And here I think all of this is bend to anim. Just this one have like a little bit of freedom in the armpit here. This one will be cloth simulated, and this one bend to animation. I think that's it for this chapter. I will connect all the pieces, pipe it to the unpack node, And in the next chapter, I will start adding the sub solver, and we'll have like a glue constraint after the unpack, so we can connect pieces to each other. But this will be in the next chapter, and based on the simulation result. See you in the next one.